In this question, we're given an equation that shows the relationship between the height of a baseball after a certain amount of time. Important thing to note here is that one thing it tells us is that the ball is thrown at a speed of 10 meters per second. That piece of information is actually not necessary to solve this question. What we want to know is that if the ball was thrown at t equals 0, what is t when the ball hits the ground? In other words, how long does it take from when the ball is thrown until the ball reaches the ground? So one way to solve this problem would be use your graphing calculator, and you would just type in this equation, you replace t with x, and it would create a parabola. It would definitely be going through the origin there, and it would kind of look something like that. And what you're looking for is the x-intercept right there. That would give you the answer. Another way of solving this is algebraically, by factoring it. Because we know the x-intercept has an x value of 0, or in this case an h value of 0. I'm actually going to go over here and replace h with 0. And then now we need to try to factor this. First thing we can do is factor out a t from both terms here. We would then have t and then brackets 10 minus 9.8 t squared. Oh, sorry, not t squared anymore. It would just be t over 2. Now, separating these, we would get that one factor is a t value of 0, which we already knew. And then now we need to set this equal to 0 and solve. So if we set, I'll change the color, 10 minus 9.8t over 2 equal to 0, what is t? Well, if I move that fraction over to the other side, we would then have 10 equals 9.8t over 2. We could then get rid of this fraction by multiplying both sides by 2, and we would have 20 equals 9.8t. Finally, the last thing we could do is just divide by 9.8. By doing that, we're isolating t. That gives us a value of 2.04 dot dot dot. It's a irrational number, but we can see that it would round to a value of t equals 2, which is option C. All right, I hope that was helpful, and thanks for choosing JD's Prep.